Welcome to Just Math, y'all. In this video, we're going to continue working on the functions unit practice test. We're going to start with number 7. Here we go. So with this one, we have a graph and we've got to determine the domain, the range, the x-intercepts, the y-intercepts, the f of -3 and f of -1. So here we go. The domain, you have to know what domain is. It's bottom to top. No, it's not. Domain is left to right. And the range is bottom to top. Let's get it right, Miss Cox. So if we look at the left of my graph, I have an arrow. That's negative infinity. Look at the right of my graph, I have another arrow. That's positive infinity. The domain of this function is negative infinity to positive infinity. When I look at the bottom of my graph, I have this point right here, and range is y values. So that's -3. And it's an actual point, so it gets a bracket. The top of my graph is way up here, and it is an arrow, so that's positive infinity. There you go. The x-intercepts are the points where it crosses the x-axis. So the x-intercept is here at -4, and I have another one here at +2. Those are my x-intercepts. The y-intercepts is where it crosses or touches the y-axis. So my y-intercepts is right here, and that is -2. Now f of -3 is asking me for the y value associated with the -3. So -3 is the x, and I have to figure out the corresponding y value. So when x is -3, the y value is -1. When x is -3, y value is -1. This point right here is -3, -1. So x is -3, y is -1. F of -1, well, here's -1 for the x. Again, it wants the y value, and that would be -3. So that's number 7. This can be very confusing for people, but don't let it be. It's really not that hard. That's number 7. Let's move on. Number 8. Number 8, we're finding the domain. Now, we have several rules that we have to use for finding the domain. You need to have those memorized. Real fast, the first one is the default. The default is negative infinity to positive infinity. Then we have a rule for fractions. We have a rule for radicals. And basically we have to look out for both fractions and radicals. So now this problem has a fraction. And the fractions, you set the denominator equal to 0 and solve. So let's do that. So I have x squared plus 3x minus 54 equals 0. This is a quadratic, so I'm going to factor it. Multiply to give me 54 and subtract to give me 3. How about 6 and 9? And so that would be a +9 and -6. So x plus 9 equals 0, meaning x equals -9. And x minus 6 equals 0, x equals +6. Technically, these are the numbers that are being thrown out. X cannot be -9, and x cannot be 6. So -9 and 6 are actually holes in my graph, and my domain is everything but these 3 points. We use the number line to help us with our interval notation. So our interval notation, from left to right, we have negative infinity to -9, jump -9, and go to 6, jump 6, and go to positive infinity. Put our unions in there. So there is my answer. There is the domain of that function. All right, we'll do another one of these in a little while, but this one, number 9, is different. Number 10 is just like what we've already done. We did these before. We did these back and forth in 3, 4, and 5. So 3, 4, and 5 are just like 9 and 10. Determine whether the following function defines function as y is equal function of x. And basically, can we solve for y? Yes, we can solve for y. Yes, I can solve for y. Y is equal to -x squared plus 16. So yes, it is a function. And guess what? Number 10 is already solved for y. Number 16 is already solved for y, so yes, it is also a function. Moving along, number 11, back to domain. Okay, back to domain. 9 and 10, I don't know where they came from. Problems are out of order. Back to domain. Remember, we have the 3 rules. The default, it's negative infinity to positive infinity. We have a rule for fractions. We have a rule for radicals. And we have a rule for both. We have both. Okay, this one's a radical. The radical is to set the inside greater than or equal to 0. That's what we're going to do. Here we go. So I'm going to take the 5x minus 35 and set greater than or equal to 0. I'm going to solve this. I'm going to add 35 to both sides. And then I'm going to divide both sides by 5. And x must be greater than or equal to 7. So on my number line, I have my domain is all the numbers that are greater than or equal to 7. So there's 7 and all the numbers greater than or equal to 7. There's my domain. And so that would be bracket 7 infinity. There it is. There's my domain right there. That's my answer. Number 13, this one's both. We will do both rules. The first one is a radical. It says set the inside. I'm going to do the radical first because it's on top. Set the inside greater than or equal to 0. Sorry. So I'm going to add 1 to both sides. X is greater than or equal to 1. Okay, so on my number line, I have 1. It's greater than or equal to 1. All right, there we go. We're not finished yet because we haven't done the bottom. So now the bottom part says x minus 2. This is a fraction. So the denominator cannot be equal to 0. So x minus 2 equals 0. Add 2 to both sides. X technically not be 2. Well, here's 2. And an x cannot be equal to 2. So we got to go in with my eraser here. And we've got to put a hole right there. Oop, I erased too much. We have a hole right here. So my domain is all numbers greater than or equal to 1 except 2. We're skipping the 2 here. And so as interval notation, it would be bracket 1 all the way up to 2. Skip the 2 and go to positive infinity. That's the domain for that one. It's all numbers greater than or equal to 1 except 2. Think that through. All x's greater than or equal to 1, but not 2. That's what that is right there. That's number 13. Okay, one more for our break. 2 more. So we have a function, and we want to evaluate. Again, what evaluate means just to plug in. So we're just going to plug in. What we're going to plug in? We're going to plug in what it tells us to is plugging in h negative 2. So that's 5 times negative 2 minus negative 2 squared. Watch your signs. That's a negative 10. That's a 4. Be negative 14. Be careful. Watch your signs on that one. Okay, so on number 14, we're going to use our graph to determine increasing or decreasing or constant. Again, we're using our interval notation. And these are subintervals of our domain. So I'm going to go left to right. All right, so now from the left, we see this is constant. And we see this is increasing. But we're only going to look at the x values. We're only going to look at the x values. So increasing, we start at 2 and go to infinity. x2 to infinity, it's increasing. Decreasing is never. Constant, we start at negative infinity and go to 2. So those are our increasing and decreasing and constant intervals for this particular graph. All right, practice this one. It's no big deal. Okay, come back for the next video. That was 7 through 14. We'll come back to the next video. and pick up at number 15, which is this one, if you want to think about it, and then come back to it.